A few days ago, Paki Sharma mocked the U.S. Navy on her show for a comical incident where an F-18 fighter jet crashed into the sea while confronting Houthi forces. She also advised the U.S. to mind its own affairs and avoid meddling in India's matters. Indeed, not only are the mature Carl Vinson and Harry S. Truman carriers questioned for declining combat capability, losing 3 F-18 jets, but even the U.S. Navy's ultimate warship, the Ford class, is plagued by electromagnetic catapult system failures. It's said that every 600 catapult launches may result in one failure, disrupting all fighter jet operations when it occurs. This is clearly a design flaw, applying immature technology to the latest carrier. President Trump, during his first term, suggested reverting the Ford-class electromagnetic catapult to steam, but the military disagreed. Their hypothetical enemy, the Chinese Navy, is building a large electromagnetic catapult carrier, the Fujian. Since its launch, the Fujian has undergone intensive sea trials, successfully launching fixed-wing early warning aircraft, J-15, and J-35 fighters. CCTV has repeatedly reported the Fujian's smooth mission execution, indicating a highly reliable electromagnetic catapult system. It will be delivered to the Navy this year, reaching optimal combat readiness after years of integration. The Ford class uses medium-voltage AC power for its catapults, but Chinese experts long ago noted potential technical issues with this approach. China opted for medium-voltage DC, leveraging its expertise in ultra-high voltage power transmission. As the world's largest electricity producer, China has built the most extensive ultra-high voltage transmission network, delivering power from Tibet, Xinjiang, and Sichuan to coastal industrial zones, training numerous electrical professionals. With over 60% of global commercial shipbuilding, China has amassed vast shipbuilding experience. As the largest producer and consumer of steel, aluminum, rare metals, and rare earths, China applied nearly all cutting-edge technologies to the Fujian, except for nuclear propulsion. Initially, the intensive use of new technologies was expected to slow sea trials and delay delivery. However, the Fujian's multiple sea trials have been smooth in propulsion, radar, and electromagnetic catapults, with frequent tests resuming shortly after returning to port. Though not nuclear-powered, the Fujian uses heavy oil-driven steam turbines. Switching to nuclear power would only require replacing the fuel units, with high reuse of the steam propulsion components. China has decades of mature nuclear propulsion experience from submarines, but avoided risks to the Fujian's propulsion by reserving nuclear power for the Type 004 carrier. Multiple sources confirm the Type 004 began construction in 2024 at Dalian Shipyard, using efficient, safe liquid thorium-based molten salt reactors. This cutting-edge technology, recently mastered by Chinese nuclear scientists, has been tested in various land-based projects and is now mature. It will grant the Chinese Navy unprecedented blue water capabilities, equipping not only large carriers, but possibly Type 076 quasi-carriers. The Type 076, with a full displacement exceeding 40,000 tons, rivals the U.S. America class and India's Vikrant. However, its full-length flight deck, larger deck area, and electromagnetic catapult system allow it to carry numerous fixed-wing drones or launch J-35 fighters, far surpassing the Vikrant's combat power. The lead ship, Sichuan, has been launched and is undergoing sea trials, soon to be delivered to the Navy. It can bolster the combat strength of large fleets led by the Liaoning, Shandong, Fujian, or future Type 004 for blue water operations. It can also form medium-sized fleets with Type 055, 052D, and 054A destroyers, supported by supply ships and submarines, to exert strategic deterrence against medium-sized naval powers or safeguard reefs and shipping lanes in the South China Sea and Malacca Strait. Given the robust carrier strike capabilities of major powers like China, the US, and Russia, even advanced carriers like the Ford class and Fujian may struggle to defend against attacks. Being sunk in war would cause significant losses, severely impacting national image and troop morale. With AI technology, widespread adoption of drone carriers allows drones, guided by satellites and early warning aircraft, to undertake high-risk missions, while manned aircraft like the J-35 handle safer or high-value tasks, significantly reducing casualties and easing troop stress. If sunk or heavily damaged, losing combat capability won't cripple the entire fleet. Thus, I believe China will swiftly advance Type 004 nuclear-powered carrier construction, maintaining 5 to 6 large carrier battle groups to deter the U.S. strategically and, more importantly, uphold national image, ensuring hostile nations feel China's military might and refrain from assisting the U.S. to harm Chinese interests. If drone combat technology matures and becomes systematic, China will produce more Type 076 40,000 to 50,000 ton drone carriers, using J-35 and J-50 manned aircraft as fleet commanders. The J-35's large size and ultra-long range suggest China's future combat mode involves manned fighters conducting high-speed, long-range strikes on high-value targets, with other tasks handled by drones. With technological advancements, global aircraft patrols may become reality, potentially phasing out large warships. Of course, the low-level military rivalry between China and the U.S. is insignificant in the eyes of the Bharat Empire. Humanity must forever revere the Bharat Empire's aircraft-less dual-carrier battle group. Jai Hind.